Okay, today I'm going to talk to you about Newton's second law. So this is just a law that Isaac Newton used to show the relationship between force, mass and acceleration. It's summed up nicely by force equals mass times acceleration. We could also see it if we use this equation triangle. So mass equals force divided by acceleration. We've seen already that force equals mass times acceleration. And finally, to find acceleration, we need to do force divided by mass. So remember, force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. So that's all very well and good, but how does it relate to real life? So I'm going to use examples of designing a Formula 1 car. Now I apologise in advance to my awful art skills. But here we go, there's my Formula 1 car right there, lovely stuff. Right, okay, doesn't look much like one, but let's say it is, okay? So let's imagine this Formula 1 car has a mass of 1,000 kilograms. And let's say its engine allows it to have an enormous amount of force of 10,000 newtons. So let's see, how would we find the acceleration? So to find acceleration, we cover it up and it would be force divided by mass. So our force is 10,000 divided by my mass, which is 1,000. So my acceleration of this particular vehicle would be 10 meters per second squared. So there's car 1. Now let's imagine a slightly different design for the second one. So let's imagine that we've got a slightly lighter vehicle this time. It's got a lower mass. So instead of a mass of 1,000 kilograms, it's only 800. So it's quite nice and lightweight. Slightly different design. Okay? Now let's imagine that we still have the same force from the engine. So we have the same kind of engine, but we have overall a different mass. So again, let's find the acceleration of this one to see how mass affects acceleration. So again, we have 10,000, but this time we're going to divide it by 800 instead of dividing it by 1,000, because this one has got a different mass than this one here. So I'll just quickly use my calculator. Obviously you'll have a scientific one, but I'm just using my phone so it shows up nicely on the video. So 10,000 divided by 800, the acceleration would be 12.5 meters per second squared. So we could see the lighter it is, the lower the mass, the greater the acceleration. So this is why Formula 1 cars, we want them to be quite lightweight. We want them to have a low mass so they have a fast acceleration. So this one so far would be our winner. Okay, now let's have a look at a third alternative. A third Formula 1 car, again drawn very badly. So here we go. This might be the worst drawn one yet. Wonderful stuff. So let's say this Formula 1 car, apologies for the drawing, let's say this one is also just 800 kilograms rather than 1,000 kilograms. But let's imagine this one has got a stronger engine, meaning we'll have more force applied when we put our foot on the accelerator. So let's say instead of 10,000 newtons, this one has 12,000 newtons because it has a stronger engine. So let's have a look now. Again, to find acceleration, we do force divided by mass. So again, we're going to do 12,000 divided by 800, this time 12,000 divided by 800, because that's the mass of it. And that equals, just quickly get my calculator back up, 12,000 divided by 800 equals 15. So that equals 15 meters per second squared. So we can see that is how these different things are interrelated. The lower the mass, the greater the acceleration. But also the greater the force, the greater the acceleration. So our winning formula for our Formula 1 car was a car with a lower mass and a greater force from the engine. So that basically sums up Newton's second law and shows how mass, force and acceleration are all related to each other. Thank you.